The universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Okay, so where is that thing that? Oh, hey, are we
Hey.
live? Are we live or something?
Yes, Mark, we're live.
Oh no, I didn't even comb my
Did you
hair.
forget again?
I know, right? It's like, that's right. I forgot me again. I always forget me. I leave myself all kinds of places.
Wherever you go, there you go.
That's right, and that's where I leave me. Wow. Hi, Tara.
Hi, Mark. How you doing?
I'm good. We haven't had a live show in a long time. I almost forgot what you look like. No, I didn't. I
It's
didn't.
been a few weeks, but
Yeah, it's been a while.
yeah.
No, I was thinking about tonight's show, thinking what we might talk about, and there's a few things I want to talk about. I did want to lead with a couple things. First of all, those of you watching the show, you may be aware, we have our remote observatories around the country. We have one in Arizona right now. We have a solar observatory going in here. We have a second observatory going in out in Arizona. I keep saying that over and over. However, we're making movement now, and Tara, of course, is part of the whole process, being part of Sky Tour live stream. As you can see in my shirt, it says STLS, and she's got it too. She's wearing hers as well. And this is, of course, Sky Tour Live Radio.
Yeah.
Okay, Sky Tour Radio, and so Sky Tour live stream is the observatory live stream, which will be occurring after this broadcast. All right, it'll start at 10:15 tonight. We'll be broadcasting live from the observatory. Eastern, thank you.
Yes.
Yep, we'll be broadcasting live once again and checking out the beautiful sky in the deep, dark Arizona desert, where Tara has unfortunately had to go so many times to, maintain and do things. Marianne, the other of the Happy Triumvirate, just went. That's right, and she did a really good job. What we do is we take that telescope and we point it. I'm in Connecticut, and the telescope's 2,600 miles away, and so I'm running it from here in my bunker. My bunker that has portholes for windows. Okay, because I've got a ship design for my office here, and while running it, I get to tell the computer and the telescope what to do from here. It goes to different objects, and I show people these different things. And as an astronomer, that's what I went to school for, as most of you know. I tell people what they're looking at, and I share with them the latest information about the phenomenon that we're looking at. You can be sure that when it comes time for Betelgeuse to go supernova, we will be broadcasting that if we can catch it. Okay. And you know what? We have another star that's going to go nova, not supernova, in the near future, and that is a star with a capital T, Corona Borealis.
Stands for Terra, Corona Borealis.
It's Terra. Yeah, she's being a Terra Mater. That's her license plate. I make her Terra Mater. Yeah. Terraminator. That's right. Yeah. Yeah. So I think it's kind of cool. So we watch for those things. There was, as you know, an asteroid came winging by us lately, a very, very small asteroid, and it's only just over 30 feet across, but it was far enough away so that almost no telescopes on the entire planet could see it. So we couldn't take our telescope and see it either. Only spaceborne instruments and some larger mountain-based instruments could actually capture it. So we could not do that. So we didn't have that to show. But we always check out the eclipses, and we're one of 5 groups on the planet, I know I talked about this before, that actually caught a meteor hit the moon at the height of the eclipse. You see the actual strike. Boom. You see
what are the chances? That's just amazing.
It is. Now, the moon gets hit Yeah, the moon gets hit quite often, Tara, but it doesn't get hit right in at the height of an eclipse where the moon is blood red, and
Right.
it was blood red in the lower left quadrant, and we saw that flash right at that point. I thought that was pretty cool.
That's
Yeah,
amazing.
yeah. So that's what Sky Tour live stream is all about, and we're on YouTube.
That,
If you go to YouTube and put in, either my name, which I think is right here, right? That's Cram. Oh,
oh,
not Ned Cram. Oh no, wait, Mark D'Antonio. I had to
tend.
look at it the right way. Yeah, and I won't say her name backwards because it's not complimentary. Okay,
So I've
but
never heard it before. Never.
really, my God, yeah, but would be when you can look it up under my name, or you can look up Sky Tour live stream,
Hmm.
Sky Tour Mark D'Antonio, whatever, and you'll see it. And um, if you go to YouTube, uh, youtube.com and then slash and then put the @ sign and then STLS Sky Tour live stream, okay, it'll also bring it to the channel. All right. So there's a number of ways to get to us. We're on Rumble, we're on YouTube, we're on Twitch, we're on Trovo, Facebook.
Hmm.
We have
You
Facebook.
name it.
Yeah, we're all over the place, right?
Yeah. And
Twitter,
still
Tweeter,
growing. Yeah.
X, whatever, X Tweeter.
I
Yeah,
don't know.
Tweeter. That's a good one.
All
Okay.
those acronyms we're on.
Yeah, I know. All the acronyms we're on. We're on
Yes.
all the acronyms, as Tara said. That's right.
Or not.
Or not. That depends.
Yeah.
Yeah. So tonight at 10:15 Eastern, we'll be going live again from the observatory.
Cool.
You can join us on YouTube or Rumble if you want. Anywhere you can join us right here. Just knock on the door, but make sure you knock before we go live. I don't answer the door during the stream.
Mhm.
Just kidding. So tonight I thought we would talk about a couple things. One of them that's really cool is the concept of what would happen in the very real world, an absolute real world response,
Okay.
if we actually did have an alien landing that everyone saw. Okay.
Mm.
In other words, we're used to the government's covering it up. They already did. The government's covering it up. Roswell, Socorro, Aztec, all those things. Yeah. Okay, fine. Okay. All that, I get you. But what about the real world implications? What would happen if an alien civilization emissary or life form of some kind decided to land in a public place like Central Park, New York? Okay. Now, everybody would like to jump to the conclusion, oh, yeah, well, people there will just shoot them and, pull out their guns and start firing. And that might happen. But I tend to
Probably.
think there'd be something else, too. What do you think, Tara?
Well, I would hope there'd be something else. And I think that's interesting that you say they land on the lawn because, again, I think it's contextual of how they come and what's happening. And I think, well, like most people, I'd probably be scared to death. But then again, like some people, I'm thinking, Mark, personally, I may not, I may just, I don't know. It may not bother me at all. It may not
Yeah.
change my life. It may
Yeah.
not do anything to me.
I thought about this, like you're just suggesting. I thought about this and thought, what would I do if the reality was they were here and it's on the news right now? How would I react?
How would you react, Mark?
My reaction is, thank you for asking. No.
I'm curious.
My reaction would actually be something along the lines of, well, it's about time. It's about time. I wouldn't be, oh, wow. Oh, I'd be like, yeah, it's about time. And I would know that they're not violent toward us. And the reason I would know they're not violent toward us is because if you work with your civilization to reach a point where you can travel interstellar, and there's really only one real way you can actually do it in a reasonable amount of time. That's the thing I lecture about all the time, all over the country. And that's the interdimensional travel. Avi Loeb is on board with that too, by the way, at Harvard. He also thinks that. And so the only way they can travel is that methodology. And if you have a civilization that commits time and resources to that type of mode of travel, then it means that you have gone past any of the points in your evolution where You're going out there to get resources or energy. You're not here to take the oceans. You're not here to eat humans. All right. That's There's food aplenty elsewhere. And if you can go interstellar, you've solved all those problems of energy, hunger,
Mhm.
medicine. All those things had to have been solved before you invent this type of technology.
Do you think
So
so?
I do. I think there'll be explorers. I think there'll be scientists and explorers from another part of the universe, and I don't, or
Okay.
a multiverse, perhaps. I don't know.
Hmm.
But the thing, and the reason I think that again, the hurdles that a civilization has in order to overcome a nuclear age, because they'll all have a nuclear age at some point. They'll all
Hmm.
discover the power of the atom, which is the same throughout the universe. So they'll discover fission, splitting atoms to make energy. They'll discover that. We did, and we made nuclear reactors, nuclear bombs. Okay. And then they'll discover fusion. We've already experimented with fusion, and I don't mean in energy ways, but in also nuclear bombs. We have bombs that are fusion bombs as well. Okay. Fission and fusion together.
Right.
So we have that going on as well. Right. So, but we're still looking at fission and fusion as a way to make energy and also to make war. And that's something that is just not healthy for the longevity of a civilization, right? So, I think that if you look at the concepts of nuclear fission, all civilizations will encounter that
Hmm.
at some point. And they'll use it probably for energy, as we have, and probably for war at some early part of their evolution. And then they'll discover fusion. And fusion is not as volatile as fission. You know, when you have a fusion reactor, like we have fission reactors now,
Right.
all right? Chernobyl was one, 3 Mile Island was one, Fukushima was
Ruh-rohs.
one. Yeah,
Ruh-roh,
those are
ruh-roh.
accident. And when you have
Mhm.
accidents with those, well, the accidents tend to cause problems throughout your country because you get radioactive debris that will shower down and fall out from the meltdown that might happen at your nuclear reactor. Okay. But in a fusion world, if a fusion reactor goes out of balance, unlike a fission reactor where you're splitting atoms, in a fusion reactor, you're compressing them and slamming two hydrogens together to make a helium atom effectively. Okay. They're all isotopes, but those are different variants of the same atom. Okay, if you have a fusion reactor and it goes out of balance a little bit, all it does is shut off. It doesn't
Oh.
go, doesn't blow up. It doesn't melt down, and the red lights don't start
Mm.
spinning and say, "Oh no, let's get out of here. Let's evacuate."
And
You know.
then
So
the tidal wave doesn't come, and then
yeah, and if a tidal wave did come, that's a very good point. Thank you. If a tidal wave did come, like in Japan, Fukushima,
Mhm.
it shut down the generators, the diesel generators outside the building. They were swamped with seawater. So what happened? They shut down. They shut down, and now you have a problem where you can't circulate water around the spent fuel rods in the spent fuel rod pool because the spent fuel rods are every bit as radioactive as the ones before they were used. And so they're just in a different form that you can't utilize for energy at that point. But what they do is they boil the water away. And when they boil all the water away, they melt and congeal into a mass. And that melted mass can do some really bad things. In the case of Fukushima, it ignited hydrogen gas in that contained building, which blew the lid off. That was the explosion you saw, was a hydrogen explosion, kind of like a Hindenburg, but contained. So it was blew the lid off.
Yeah.
Okay. So we don't get that with fusion. With fusion, it just shuts off and you
Nice.
leave and Frank over in the corner is going to go, "Oh, I got to figure out how to turn this thing back on now. What do you think, Bobby? How do we do this? Oh, I think we got to mix a few of these. Give me some of that tritium there, Frank." I mean, you get it back in balance and you can get it running again. But fusion is different. And
Mhm.
so that's the next hurdle that we need to reach. So every civilization is going to reach these hurdles. It's going to reach It's going to probably have seen some fossil fuel of some kind. Maybe there's other animals that made coal. Maybe they found it. Maybe they didn't. But they're going to find it. They're going to have a nuclear era.
Mm.
And after the nuclear era, they're going to have a fusion era. And the fusion era is going to lead to literally a hundredfold expansion in capability
Mm.
because you'll have a fusion reactor the size of this glass. Okay. And you could probably power it with something akin to water effectively because water
Wow.
is an ample supply of hydrogen, two for every molecule.
Yeah.
I just drank some of that fusion fuel. So there's a lot, right? So they'll reach that threshold as well, you see. So,
Well, so if they're going to come here and you say they're very smart, they would have done studies on us, right? I mean, you think that they would anticipate what our reactions might be, and I'm wondering what you think they might think our reactions might be. And that may be a silly question, but don't you think that like War of the Worlds, there would be some panic still amongst people?
oh yeah, you're absolutely right. There will be panic, and people will say, "Oh
Mhm.
no, it's the end," you know. And for me, I'd be saying it's just the beginning. You know, I wouldn't think of it as the
Or
end.
it's
I mean,
the
it'll
middle.
be yeah, it'll be nerve wracking, right? I mean, we're gonna
Mhm.
wonder what are the motives. Okay, obviously,
Yeah.
you think about them as scientists or explorers. You think, okay, they may not want to hurt us, but then again, if they're that far advanced, they may not know they're hurting us, and that's something. Their
Mhm.
ordinary activities could hurt us. Give you a perfect example. Okay. Um, there are cases where people approach a UFO in the reports, and when they touch it, they get burns.
Mhm.
Okay. Some people actually have patterns of burns on their bodies, resembling what they said were vents
Right.
on the UFO. Okay. Where that was it real? Don't know. Were they lying? Maybe. But what if it was true? Okay. And I, in what I talk about with the interdimensional travel, the methodology by which they travel is to generate particles through what might look like those vents to surround the UFO
Mm.
and take it into this fifth dimension. And this fifth dimension is the place where the you would move in that fifth dimension from one place to another. What it is a much more compact, compressed universe that's around you. So 12 inches of movement out here in our four dimensions. In there, the farther in you go, the more compact the universe is. So 12 inches of movement, so to speak. I know it's a simple analogy, could correspond to the distance from here to Pluto when you come back out.
Mm.
You know, so what if you move 100 feet in there? Okay, 100 of those 12 inches, maybe 100 times further, or more, depending on how far in you go. So that mode of operation is the only way they can actually work. And my friend Bob Schroeder came up with he has a book called Solving the UFO Enigma, and it talks about this. And Bob is really knowledgeable. He's very good, easy to talk to. And his theory, I think he's got it. And I'm not proud if I didn't think of it. So what? If someone else did, I'm happy to talk about it. But I have joined forces effectively, and I think that that's the only way that it can work. It's the only way it can work. So,
Mm.
would we panic? Yeah, I'm sure there'd be people that are not going to be happy about it. Okay, especially the people in power.
Oh yeah.
Wait, there's a greater power than the president of the United States and the president of Russia. There's a greater power than the president of China. What's going on? Those are narcissist people that will expect that what they do moves and shakes the world. What if they found out that they can't move and shake the world because, oh, I don't know, the world doesn't really belong to them? What if
Mhm.
it's a shared property? Might very well
Right.
be. Might very
Right.
well
And
be.
for billions of years or millions of years that we've been here. I mean, it just could be
Mm,
another part of our reality that we haven't
that's right.
woken up to.
Yeah. If you think about this, I mean, 4.6 billion years, that's how long the Earth has been forming. I say been forming. There's still stuff going on. Our core is doing interesting things. It's always
Volcanoes.
done them. Yeah, yeah.
Yeah.
The Earth is always reshaping itself. All that stuff. But if
Cool.
you think about it, in terms of the planet itself, we could be a shared property. And it means we could be sharing it with another group or groups of people.
Groups.
And there's a reason why it's not unfounded to think about that. And it's very important for people to realize. And I'm going to tell you, and I think you might know this because we might have talked about it. If you look at what makes Earth different from other worlds, let's just stick with our solar system for a minute. Let's look at Venus. Venus atmosphere is mostly carbon dioxide, 90 times denser than ours. Temperature on the surface is 900 degrees Fahrenheit. Okay. The pressure is 90 times the pressure on our surface. So we're 14.7 pounds per square inch. Every square inch, you're getting 14.7 pounds pressing down on you. I know. But because you were born into it and evolved into it, doesn't feel like it. Just like the fish at the bottom near the Titanic, swimming around the wreckage of the Titan submarine. All right. That imploded in a millisecond or two, and there's a fish swimming around the wreckage. Well, why isn't that fish imploding? Well, because the fish evolved there. Now, if you take that fish rapidly to the surface, guess what? It blows up. Yeah. And that's what happens. Because they're not used to it, it'll kill them. So we've evolved under this atmosphere. So Venus, it wouldn't work well for a carbon-based life form like us because carbon bonds can be broken by high temperatures and pressure. And so high temperatures and pressure are not good for carbon-based life like us. All right, well, let's go to Mars. All right, Mars. Well, Mars has a much thinner atmosphere. Actually, it's quite a lot thinner. It's only a small fraction, less than 1% of what ours is. And it's mostly carbon dioxide, 98%. Now, we need to have oxygen to survive. Yeah.
Yeah.
Yeah. Now, we, to our testament, to our ingenuity, we as humans have created a mechanism on Mars that is with the Perseverance rover. It's called MOXIE. It stands for MOXIE. It stands for Mars Oxygen Experiment in Situ. It's MOXIE. So what it does is it generates oxygen, breathable oxygen, or oxygen for creating fuel, as we need it now, rocket fuel, by extracting it from the CO2. Because remember, inside a carbon dioxide molecule is an atom of carbon and 2 atoms of oxygen. Let's get that oxygen out of there. And now we have oxygen. And that's what the MOXIE unit successfully did. It was the size of a car battery. Okay. And it made oxygen. So the question becomes, if we go to Mars with people, do we have to take oxygen with us? The answer is no, we don't. What we can do is use one of the inflated-tats, as I call the inflatable habitats, put it on the surface, and have an automated MOXIE system, which will put oxygen into it, making a breathable environment for the explorers.
It's an oxygen bar on Mars.
That's exactly what it is.
Mm-hmm. Right. Nice. Heads will hang out.
Yeah.
So they couldn't do that in Venus, or like in the clouds. I mean, we couldn't, because isn't that where we'd have to be? Is in the clouds.
Very, very good point. That's why she's here. Okay, Venus, the Venusian pressure is very high, as we already talked about. But in the upper cloud layers of Venus, it's actually rather pleasant, if you will, kind of okay. The only problem is that on Venus, in the atmosphere of Venus, because of the nature of the chemical abundances in the Venusian atmosphere, there's a lot of H2SO4. That's 2 hydrogens, sulfur, and 4 oxygens all combined together. When you combine them together, H2SO4 is sulfuric acid.
Oh, that doesn't sound good.
No, you don't want it'll melt your face off. I'm going for a walk. It'll melt your face off. You don't want that. Okay. And there's a predominance of those droplets in the Venusian clouds. So we would have to first have a way to negate those from reaching us in the Venusian atmosphere. We'd also have to have a way of floating in the Venusian atmosphere. That means some kind of a balloon structure or something. You imagine if the balloon springs a leak, you're going to sink deeper and deeper into your doom, where you feel the pressure and suddenly, and you're nothing again. That's pretty bad.
Nah, doesn't sound
So
good.
it's a little more difficult. Getting to Venus is actually not that much less difficult than getting to Mars. Okay. Going to Mars and going to Venus, going to Mercury, those are all actually hard to do. Going to Mars, let's say we can do it. Let's say we have the trajectories. We go to where Mars will be because it takes so long to get there, right? If it takes us 10 months to get to Mars, Tara, Mars is coming around in its orbit. She'll be coming around the orbit when she comes, right? Going around, right? And we don't aim for Mars, okay? If Mars is way out here coming around, we're heading out this way. We're going that way. And when Mars, and when we finally reach where Mars is, then we'll reach it and we'll intersect it. We don't go to where Mars is now because then it's going to be hopelessly past us.
Right.
We have to go where it's going to be.
Yes.
That's pretty cool. But again, Mars, can it be terraformed? I think so. Mars has lots and lots and lots of water. Okay, lots of water locked up. The Phoenix lander on Mars was in the mid-northern latitudes, and it landed on a layer of the dust, the typical reddish brown dust that we all see on Mars.
Mm-hmm.
And right under that reddish brown thin layer of dust, which is just a dusting, it was rock hard ice, as hard as granite. Yeah. And there's tons of, and that was water ice. So there's tons of water ice on Mars. And they actually found that deep under the south pole of Mars, right? Under the south pole of Mars, there's actually a reservoir of actual water. Why would we have actual water? Why can't it be on the surface? On the surface, the pressure is too low. But pressure comes from many sources. On the Earth, the pressure is from the atmosphere. There's so much of it that you get 14.7 pounds, as I said, per square inch, right on your head and your body, every single part of your body, in your armpits, your legs, everywhere, on your butt, top of your head, in your eyes, in your ears. Okay. So, yeah. So on Mars, though, the pressure from the atmosphere is far less. Okay. So where would the pressure be more? The pressure would be more if you were deeper underground, where you had the weight of the rock above you. Okay. So now, because Mars does have gravity, albeit a smaller gravity than ours, he says it's like 0.3 or something. If you look at the gravity of Mars, it would actually cause that rock strata to weigh enough that at a certain depth you could have liquid water. And sure enough, radar studies below the south polar cap, which is mostly water and carbon dioxide ice, have shown that there's water there.
Awesome.
It's like a 12-kilometer reservoir that they caught,
wow,
underneath there that they could see. And now, because it's in the rock strata, it's very likely going to be very briny, so highly salty. Okay. But if you think about it, that's a wonderful opportunity for small microorganisms to form. And again, I wouldn't think that there could be life there had we not gone to the deep ocean sulfide chimneys that are off the Juan de Fuca Ridge off Oregon or at the Mid-Atlantic Spreading Ridge, and found that there's a little microcosm of life around these chimneys. They've never seen the light of day. No, that's right. And they've never seen the light of day.
Yeah.
But they still saw the light of life. And the reason had to be because of the opportunity for life to form. And so on Mars, in the deep aquifers, those deep underground water reservoirs, it's possible that a chemosynthetic life form, just like at our large sulfide chimneys under the ocean, could have formed. Okay. Same thing on the moon Europa, Jupiter. Right. It's, Europa is a moon that's it's like 1,900 miles in diameter. Okay.
Small.
And yeah, it's small, but it has what could be like a 60 to 90 mile deep ocean under its icy covering. And that ice is several miles thick. Okay. Imagine that. There's no ice sheet on our planet as thick as the European ice, most likely. The Antarctic comes close. Okay. Lake Vostok is thousands of feet below the Antarctic ice.
Oh, cool.
Yeah. Deepest lake, under ice on our planet. And even in that lake, which only saw the light of day, oh gosh, millions of years ago, a couple million years ago, maybe, there's over 3,500 different forms of life in that lake, and
That's cool.
probably more.
But you would
So
think there'd probably be life on Mars. You would think there is, you know.
exactly for these reasons,
Mhm.
and when I saw Jurassic Park, okay, it was kind of funny, because Jeff Goldblum played the part very well as Ian Malcolm, the scientist, and he looked at the guy that set up the Jurassic Park, talked about whether these creatures could mate, and John Hammond, the guy in charge of the park, said, "Oh, well, we've genetically removed that capability from them,"
Lysine.
right?
Yes.
And Goldblum's character says, "Oh, well, life will find a way. Life finds a way." Right? And I guess that's kind of silly to say it like that in terms of a movie, but if you think about it in reality, life found a way at the bottom of Lake Vostok. Life found a way at the deep ocean where there was no light ever.
Mhm.
Okay. So chemosynthesis versus photosynthesis. One needs light, one doesn't. And what are the limits on chemosynthetic life? Can we have intelligent chemosynthetic life? It doesn't appear so. Not if our Earth is any standard. We could have microorganisms. We could have filter feeding, tube worms. We could have clams. Okay, are they intelligent? I mean, I know some people that only have the intelligence of clams. Okay. On the other hand, no, I don't. I don't think that our intelligence was based on our response to the pressures in our environment, and so we evolved to succeed in our niche that we have carved out
Mhm.
here. But that's not to say that the sulfide chimney creatures aren't still evolving. They certainly are. There's certainly more species of them that will be discovered at some point, without a doubt. There's shrimp, there's
Yeah.
clams, there's tube worms, there's a lot of other creatures, there's bacteria. Okay, so life will find a way, and so maybe on Europa, deep under that ocean, that icy mantle that's miles and miles thick on Europa, I'm sure that you get into the ocean on Europa. Now, Europa's only 2,000 miles across. So in our deep ocean, the pressure is too high for us, right? And as we get deeper, it gets colder in our ocean.
Brr.
Okay.
Yes.
But on Europa, it's different. Europa is small. So the deeper you go into Europa, the water pressure isn't as bad
Hmm.
as it is in our deep ocean because it's not as deep by any stretch. It's
Right.
only yeah, but then when you get down, say 3/4 of the way to the end of that ocean, and this is all speculation, of course, the temperature of the water could be 75 degrees Fahrenheit,
Oh, perfect.
right?
Just perfect. Yes.
Dark, but maybe 75, because the
Nice.
what's happening is as Europa goes around Jupiter, all the other moons are kneading Europa, Kneading, like bread. They're squeezing it and causing it to do this and that. That's why it has all these fissures in its surface and cracks. It's being kneaded like dough. And as it gets squeezed, that heat is translated into the center of Europa, where it stays warm. It's also warm in the center because of uh, the original formation. Heat of original formation is still there. Okay.
Hmm.
But as it needs, it's actually keeping that moon warm. So that's also why it probably is an ocean below that ice. See? So it's interesting because there are things that were found in Europa are fascinating, and that is that we see on Europa that um, we have these cracks and stuff, but there's little brown stains every now and then that have blown through from the ice below. Little farts of brown material. Okay, that's a
Nice.
really bad joke. Okay, I said it
Nice.
and they thought of it at the same time. Okay, and Europa has what are called freckles. It's these stains of brown on the ice, and as it turns out, those are carbon-based compounds. They're building blocks of life
Hmm.
spewed out from the interior of Europa. And we also discovered that Europa has geysers. Okay, you can see stuff spewing up and everything. Saturn's moon Enceladus has the same thing at its south pole. So I think it's really cool that we have that happening. So here in our own solar system, although our planet is the only one suitable for real carbon-based life forms to take hold and evolve in a way that will allow them to thrive, we have the possibility of life even in the coldest depths of a distant moon. Isn't
Mhm.
that something?
It is amazing. So, why would the aliens choose to come to us if there's possibilities anywhere? I mean, did they'd have to be really similar to us? Are we assuming that
You
uh,
you actually are very, very you're right on it tonight, aren't you? You're on top of things tonight,
I don't
you
know.
know? Yeah, okay.
What
Tara's suggestion, go ahead, finish your point
No,
now.
no, you go ahead, please.
I'm gonna take a sip, you think.
No, I'm just thinking about it, and
Okay.
because I think some people might already say that they're here, and then is it and then there's some high strangeness that goes along with the alien presence, and is that just a side effect of them being here in this oxygen planet, or is that and interacting with us, or what?
What was the first part of what you said?
I don't remember.
You just said it. Okay. All right. Well, let's take a look at that a little bit piece by piece, actually.
Yeah,
Um, why would the aliens come here? Let's take
right.
that first. Okay.
Here versus the other planets where they wouldn't have to deal with
Yeah,
us,
yeah. Exactly right.
right?
And
Mhm.
why would that be? Well, there is one main reason, and that main reason has to do with how we're made. When you look at someone, they're the same on the left as the right. There's symmetry. Okay.
Mhm.
Tulips are radial symmetry. Radial symmetry. Okay. Echinodermata, the starfish echinoderms, they're pentamerous. They're five-sided symmetry.
Okay.
Oddly enough, they're bilateral symmetry when they're born as larvae. And
Huh.
then they move into the pentamerous and the five-sided symmetry as they
Cool.
get old. Yeah, it's cool. Uh, so every life form has symmetry. This is probably the result of DNA and how it replicates. Remember, DNA unzips one strand and puts a complementary strand in place. Okay,
Mhm.
symmetry. So that could be the result. That could result in symmetry based on the DNA coding, radial, pentamerous, bilateral symmetry like us, like cows, you know, and
Pretty
plants.
everything on Earth, right? Or is
Yeah,
it?
yeah.
Yeah.
So
Okay.
what's the draw for an alien species? Why would they not go to Mars? Well, if they're looking at the Earth, um, anytime in the last few million years, right, then they're going to see that our planet's atmosphere is going to have a lot of oxygen in it. 21% oxygen currently. It was a little more, a little less here and there. It was going up and down,
Give or take. Yeah.
give or take.
Yeah.
Yeah. Well, that's going to be important to an alien race because the thing about life in the universe is that for life to thrive, it needs to be made of atoms that are very flexible. In your body right now, you've got hundreds of thousands, if not millions, of bonds being made and broken
Uh-huh.
every second that you're
Wow.
sitting there. Your body is a machine. It's a carbon-based machine, and it's
Mm.
breaking and making bonds with oxygen-based compounds, other carbon compounds, sugar, C6H12O6. Okay, that's a very powerful supply of energy for the human beings and for plants and for animals. It's common. So the common factors in life on our planet that make a difference, the life that stands out, is carbon and oxygen.
Right.
What's interesting about that is carbon and oxygen are the within the top few uh, elements of the most prevalent elements in the universe. Okay, hydrogen's number one, carbon is number four, okay, oxygen is number three, and helium is number two. So
Okay.
hydrogen is the most common, right? Then helium, of course. Now that makes sense because hydrogen is converted into helium in stars. That's nuclear fusion. And we'll talk about that in the next hour. But that's the kind of thing that makes a lot of sense to me. Okay. Hydrogen made into helium, therefore hydrogen is the most abundant, makes sense. It's the most simple atom too. A proton, a electron. Okay.
Huh.
Right. And once you have that, the next one that's most common believe it or not, in the universe is oxygen. It's the third most abundant element. Interesting. And then the fourth most abundant, carbon.
Hmm.
So to me, it stands to reason that if there's going to be life in the universe, it's going to be carbon based. That makes sense to me, and because the most opportunity is afforded to carbon. Okay. Now there are people that say, well, what about silicon based life? Okay, I can give you that. I'll grant you that's a possibility, but there's something we have to think about. Okay, and I'm going to show it to you right now. Okay, in this chart, if you look where carbon is, it's over on the right side. It's number 6 in the table. Let's see, it's green over there. It
Hmm.
has a 6 underneath it. Okay, the column underneath it, silicon, germanium, all the way on down.
Okay.
Okay, those elements directly below carbon are the elements most with the similar capabilities of carbon. And so the next one down is the next logical one that could possibly support life. And people have talked about, and this is why they say in science fiction, well, we could have silicon-based life forms. You know,
Right.
uh, Daryl Mason, who was in our Skytour live stream as our co-host, he'll often say, "Remember the Horta in Star Trek? It was a silicon-based creature." Okay, yeah. Well, the trouble is, silicon makes really tenacious bonds. It loves to bond with stuff. Okay, so when it makes a bond, it doesn't like to let go, and it tends to make crystalline structures. Okay, silicon,
Rigid.
yeah, silicon can make great glass.
Mm.
Yeah, but to break the bonds is difficult. Okay, so silicon is robust. Silicon tends to make crystalline structure, but silicon is also unable to bond with as many things as carbon can bond with. And most importantly, it's unable to let those bonds go through a chemical process. All right.
Mm.
Like if you heat up carbon based compounds of certain types, they will disassociate, fall apart. Okay. All right. That's important. Right. So that's how
Yeah.
we create energy within our systems. So that said, silicon is not efficient. And I make this joke a lot. People laugh at it. Okay. If when you go walking on the beach, you can use this. Okay. When people ask you, "Oh, doesn't the sand feel good under your feet?" You can say, "Yeah, it's mostly gas that we're walking on." Huh?
Hmm.
Yeah, it's mostly gas. What are you talking about? It's solid. I feel it. Yeah, that's the silicon atom. But there's two oxygen atoms in that as well. Silicon dioxide is sand. So it's a silicon atom with two oxygen atoms. So you can tell all your friends, I walk mostly on gas when I go to the beach. They may accuse you of something, okay?
Yeah, it depends on how you take that. That's
That's right.
interesting.
That's right. So anyway, so
Mm.
that's so silicon isn't very effective. So that's in short and long why I believe carbon-based life is the nature of life in the universe.
And so, if the aliens then were carbon based and we are carbon based, so there anything known to science yet about issues with the based life forms going into different dimensions? I mean, do dimensions have an effect on what you're made of? Because it's smaller and I mean, how does that affect you?
Well, okay, if you talk about um, us as carbon-based life forms moving into alternate dimensions, we can't just go in there without some type of protection. You need to
Okay.
be within the mechanism to do that. And if you surround yourself with these particular particles, you're effectively isolated from any, as we say, deleterious effects of these other dimensional worlds. And so there will be no disastrous effects imparted on you personally. Now, if you shut off your machine inside there, then
There's
yes,
an issue with the equipment.
you'll have a life-threatening issue upon you within a millisecond. Okay, it'll make the
Hmm.
Titan sub implosion look like a walk in the park, which it wasn't. Okay,
Yeah.
so clearly, you need to keep them doing this and surrounding your ship, and then um, if you can travel within that fifth dimension, you're protected within. So I think it's really cool. to think about this. And is any of this proven yet? Some has been proven. Some of this has been proven.
Mm.
Okay, the particle that we're talking about here, that you would surround your ship with, is called a Kaluza-Klein particle. And CERN overseas put a detector on the Large Hadron Collider to look for Kaluza-Klein particles in part. Okay, and they found them. So clearly, these KK particles are interesting to science, right? That's where they're leaving it right now. For what else can they do? Well, I guess we'll see in the future. But I tend to think it's going to lead to a interdimensional travel capability. You know?
That's amazing, but it'll start out really small, right? On our
Yeah,
abilities
yeah, sure will.
Mhm,
And the other thing too, keep in mind, um, you asked the question originally, why would they even come here?
mhm.
Right. Well, we talked about there because of oxygen in our atmosphere. Okay, and there's a little bit more to it than that, and I'll just clarify that, before the break here. Okay, and when you look at an atmosphere, if it has oxygen in it, the first thing you're going to do is monitor whether that oxygen is going away. Now, the reason is the reason that it comes from having observed Mars for a long period of time and looking at its history. Mars had tons of water in the atmosphere. It had a much bigger atmosphere.
Right.
But when the magnetic field within Mars died off, the sun and its high energy radiation, ultraviolet radiation, could penetrate and get down to the surface of the planet once the atmosphere thinned.
Right.
Okay. And the atmosphere thinned because of the fact that we had this H2O water vapor in the atmosphere of Mars. And when the ultraviolet radiation strikes the H2O molecules, it splits them into hydrogen and oxygen. The hydrogen gets lost to space, and the oxygen is heavier. It's an oxygen atom, so it falls back down to the planet where it bonds with the first thing it finds, and the first thing it would find is probably an iron compound.
Mm,
Okay, multiply that by 1 billion years, and you
mm.
discover that the Martian surface is covered with a fine reddish brown dust. Here we call that rust, and that's what it is. It's hematite. It's a flavor of hematite on Mars, and so Mars actually rusted. That's why it's the red planet. Isn't that cool?
Yes, it's
Yeah.
pretty.
Now
Yeah.
that dust in areas is only like talcum powder thin layer, and in others it's pretty thick. And there are sand dunes on Mars. There is sands as well. There's deserts covered with
And
this dust.
rocks, right? And
Many rocks, yeah.
mhm.
Rocks from impact, rocks from water flow pushing rocks out of the way. There's water channels that have been carved by water. There was lots of water on Mars at one point. Mars probably early on was more like an ocean planet. It had a lot of water moving around, lots of ocean. Relatively speaking, Mars probably had more water than we did.
Wow.
Okay. And we balanced out because we are at that not too hot, not too cold location around the sun, the habitable zone, right? The Goldilocks zone, as
Yeah.
they call it. Um, and so I would say that an alien race worth its salt will have the ability to look for oxygen in an atmosphere. And if they've been watching Mars throughout their development and their science, as they got to the point where they could look and see other planets and other solar systems, other star systems, just like we're doing now,
Cool.
okay,
Yes.
then if they're 1,000 years ahead of us, there's no reason they can't differentiate Mars and its atmosphere from the Earth and its atmosphere and the compositions of each. And they've noticed, probably from their ancient science, that Martian atmosphere was depleted of oxygen, and the Earth atmosphere has an oxygen level that's actually maintaining a consistent level throughout the millennia. And how is that possible? Well, is it possible to create oxygen? Because something's replenishing it, right? And the answer is that something would have to be replenishing it. Because oxygen, like on Mars, once it's free, it wants to dive down and bind up with
Oh,
anything it can
interesting.
find. So if we stopped oxygen generation on our planet, it would only be a few 100,000, maybe a million years before we could no longer breathe on this planet again, because the oxygen would dive out, and we would have nothing but the remainder of what's in our atmosphere, and it would also be a lot
Right.
thinner. Okay, and that means more ultraviolet radiation would penetrate, and the process would accelerate.
Right.
See, so
Tick, 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 tick. Time's
yes,
ticking away.
yeah, and an alien race
Mhm.
would actually probably look for signs that our oxygen atmosphere was depleting itself. And if it wasn't, then they would come to the conclusion that even though geological processes could create oxygen, certainly not in these amounts that we see on this weird planet out there, this blazing blue beacon out in the universe. So that means it's probably being replenished. And the only thing that we here as aliens in our world know can make oxygen is life. So that planet probably has life. Let's go there. Hey, guess what, Torgon? We have the way. We can use that dimensional shift thing. Oh yeah, let's go there. And so they come here and they discover a weird warring species, um, strangely different from them.
Yeah.
Doesn't look anything like them. Weak and feeble looking in some ways, and fearsome in other ways. And so the first thing they're going to do, Tara, is hide from us. Just like we hide behind blinds to look at owls and elk in the Yukon and photograph them. We tranquilize them to put trackers around them. But we'd recognize
Yeah.
a radio collar, so they have to do something more surreptitious to us. So that's
Yeah.
why the implant thing, right?
Mm-hmm.
Mm,
Yeah.
yeah, that's right. Now
That's
I think we
scary.
have to break here in a few, don't we?
We have 5 minutes. Well,
5 minutes.
yeah.
Okay. Well, I've been doing all the
Just
talking,
under
so
five.
I'm gonna sit back and now Tara's gonna.
Yeah. No, I find that interesting though. If they were to come, a lot of people think that they already are here, and we don't have proof of that. Maybe some people do, but I find it interesting. Do you think that they've already been here, Mark, or do you think that they're here?
Well, in the few minutes we have before the break, I'll tell you that based on how I think they travel,
Hmm.
I think, yeah, I think not only can they be here, but I think that more than one group could also be here.
Yeah.
Okay, and the reason has to do with the different types of UFOs that people have seen. Now, we have to literally dispense with 95% of the reported cases. We really do, because ordinary things captured in an extraordinary way. I get that.
Hmm.
As MUFON's chief photo and video analyst, I've seen a lot of things.
Yeah.
Okay, but I do know that we have to consider the possibility that not only are we not alone, but an alien species coming here is going to use a different ship design to get here, but they're all going to be fundamentally founded on the same travel principle.
Mm.
Why? Would they have talked to each other? No, they don't have to. What they do, okay, just like ancient island species discovered rafts because they saw that logs float. Well, they didn't have to be shown that. They created their own version of a raft, and other species, other civilizations on other island chains discovered their own versions of a raft and made their own style. Okay, so this is thatched grass with logs. This is just lashed logs with grass or with rope that we manufactured from our vines. Okay, so but either way, they've made a raft.
Right.
So the UFOs, the aliens, will have made different ships, and they would have used the same technique. Okay, lashing the logs. Okay, building a sail. Okay, that stuff would have all happened. It would have made it out of different
Yeah.
things, but the principle would be the same.
Makes
That's my
sense.
feeling. Yeah, that's my feeling. So
Mhm.
and that's why I think that alien species coming here could have different design of ships, but they could all be operating on the same principle. Because just like we discovered the fission age and the coming fusion age, they will have discovered the graviton particle age that we've been talking about. Pretty cool, huh?
Yeah. Very cool.
Yeah. Well, I think I expended 5 minutes there. So
Well, Yeah,
Go
we
ahead.
have 2 minutes. I just was curious, do you think they're learning anything from us if they're already here? I mean, if they're so far advanced with this, I mean, I I wonder if they're going to be here for our minerals, our resources, or to make new friends,
Uh,
influence people, that type of thing.
yeah, I'd have to say that you know, well, actually, it's weird. I just forgot your question. I'm sorry.
Well, did they come here for resources or
Oh,
to
yes, yes.
influence folks
I'm
or
sorry.
no,
Yeah.
it's all good.
Um, I feel that they're here because they're explorers and they've never seen life forms like us, guaranteed. So just like we hide, like I said, from creatures that animals that we're studying, because we know that even if they're not as smart as us, they can still stomp us and kill us. So we're going to hide and protect ourselves. Well, I think they're going to do the same thing. I really do. I think they're going to do the same thing. It's a natural thing to do. Okay, they're gonna come here and they're gonna hide from us as best they can. And we may talk about this after the break too, but I
Yeah.
think they're hiding in the deep oceans.
Oh, cool.
They're not on the moon. Okay, they're not out there sitting in a mothership at the edge of the solar system.
Mm,
They don't have to be. They could be right here, deep in our oceans. How about
wow.
that?
I think that's cool, and I think that I wanna know. I think I have a right to know as someone living here on Earth if they're there or not. So,
Yeah, and I
anyways, I
and I
think
think it's important too to discover whether this planet really does belong to us or not.
yeah, there you go. There you
Right?
go. So, but I think
Right.
that's it. Our
Yeah.
time's up.
All right, we're going to be back in a few minutes, guys. I hope you stick with us and join
Yeah.
us. When we come back, we'll talk about some stellar evolution and the creatures that could be generated by different stars. We'll be
Oh,
back.
cool.
Hey members, the new KGRA DB app is now available on iOS and Android devices. Gain on-demand access to any KGRA DB programming. Download any show directly to your mobile device to listen or watch on the go. Go to the App Store and search KGRA DB.
As UFO reports come in from around the world, the Mutual UFO Network, MUFON, is there. We continue to explore new cases and build our massive database. We share our information with the world in a number of ways. If you'd like to be part of our investigative team, you are always welcome. What could be more exciting than exploring the UFO question firsthand? Join MUFON, find your friends.
You're listening to the KGRA Digital Broadcasting Network. We provide unparalleled coverage of trending news in the world of ufology, cryptozoology, and paranormal phenomenon. Whether you're watching our video live stream or listening to one of our audio programs, you are getting the best from world-renowned researchers and hosts, guiding you through topics the mainstream won't touch. Miss one of your favorite programs? No problem. Head over to the members area at kgradb.com for access to our massive library of award-winning content. Make contact, stay connected. Only at kgradb.com.
You know, if our eyes were just a little different, this would be normal to us. That's not how our brain perceives things. So we actually are like this, right? Kind of interesting. You know, now the flat earthers would say that, well, you can't have people in Australia like this. Okay, they're looking up at us. All right, yeah, actually they are. They don't understand the concept of gravity. It's so embarrassing listening to them talk. Anyway, I was saying hi to a couple of folks out there. To say hi to Martin, who's here.
Marianne's driving home.
Oh, is she driving home? Marianne's back. Okay, yeah. Marianne's coming home. Yeah, there she is. Yeah, she's coming home from the mountains. That's fantastic. Yeah, we got a lot of people out there watching tonight. Thank you guys for joining us tonight. We're hanging out. We're talking about the actual reality that will strike when we meet an alien race for the first time. That will happen. That's going to happen. There's some that argue it has already. And Tara asked before the break if it's possible that they're here already. And I think it's very possible they're here already. And I think that we have to put together all the different understanding of all the different parts of science and observations of unidentified objects in the sky. We can't stick to just what's in the sky. And this brings us to a new problem, and that is our oceans. We have to look in our oceans as well. My very good friend Darcy Ware did an absolutely wonderful movie called Transmedium. It's about the unknown submerged objects, USOs, and throughout the world. Now it has Admiral Tim Gaudet in there. I know Tim; he's a great guy. I'm in there, but that's not why I'm saying it's a great movie. I'm saying it's great because Darcy did a phenomenal job in putting together all the sources for this. And it's funny, as much as you think you know about USOs, you watch that show, this movie, and you learn something new. It's really, really good. So, and the concept of a USO is interesting because people say, how could there be any kind of deep ocean presence? Okay, the pressure is so great. Yeah, it is. If you felt the pressure.
Right.
Now, we feel the pressure. And I'm going to say something else. I think that alien beings from another part of the universe would also feel the pressure, and it's also just as deadly to them. Okay, Mark, so why would they be at the bottom of the ocean? How could that possibly be? Therein lies the rub.
Yeah.
Okay. Not so much bubbles, okay, but dimensional shift, because they're neither here nor there. They're oscillating back and forth between this fifth dimension I've been talking about and the four dimensions where all the pressure is at the bottom of the ocean. So if they oscillate fast enough back and forth, they may not feel that pressure. And so they could stay indefinitely at the bottom of the ocean because their ships would be powered by a source that we're reaching for. And all you need to power this source to create these particles to take you into the fifth dimension is a fusion reactor. And the fusion reactor, once going, no reason it has to stop. Okay. I agree. Bark, bark. There's no reason it has to stop. So you could end up having a ship on the bottom of the ocean indefinitely. And as long as your ship is running autonomously and have your computers running your ship, to us, a computer is a bulky box that sits on our table, or little guys. We got the little ones that we use. Okay. But they might use something that's built into their own bodies. It might be biological computing computering,
That's the
computtering,
word.
biological computtering. Okay, biological computing that would actually be built into them or part of the ship. The ship might actually have organic connections to them. Yeah, we're trying to do that now. We have with fighter craft. We've done that. We've linked at a rudimentary level the eyes of the pilot to the instrumentation and the plane. So that's because looking at something really quick is faster than reaching for it and pushing a button. So to get immediate response and fast response, you tie it into the biology. And we're trying to do that, like I said. So
Yeah.
who's to say a race 1,000, 10,000 years ahead of us would not have already done that? And right now, what we do is archaic. Hey,
Mhm.
people used to fly around. I saw them in history books. These things that use the air to fly. Oh yeah, yeah. They still think that you can't defeat gravity. I know, right? But in fact, maybe we can defeat gravity by um, not allowing it to reach our ship. And that's where this
Hmm.
concept of fifth dimensional travel comes in, because in the process, you're creating these very, very high strength gravitons, a very powerful gravitational field created by the fusion reactor. And when you do that, the gravitons themselves are absorbing the gravitons trying to hold the ship down to the Earth. In other words, Earth gravitons can't reach the ship. So it just continues to flutter and float around. It may not look like it's traveling with an up or down. It doesn't have to, because the occupants don't care.
Hmm.
So there's a lot. There's a lot of overlap conceptually with what an alien species might actually develop for a craft and what we might see in our sky in reaction to it. So there's a lot going on there.
Yeah. Would would a silicone-based life form be able to come into our carbon-based environment?
Oh, sure. There's no reason. We have
So,
silicon-based objects here now.
so the would they a silicone-based alien, would they have a need to transform our environment? Like, we want to transform Mars so that we could live there. Would they need to transform a place to live, or they can just, like you're saying, they can just already exist on Earth?
Well, let's put it. I think they would probably have to have some type of difference. I'm not going to turn around
Or
and say they all
breathing
breathe
apparatus?
oxygen. They all breathe O2 like we do, diatomic oxygen. I won't say that, because is it possible that they don't? Yeah, they might have another oxygen-based compound that they breathe because that's natural for them to breathe it.
Oh.
So they might infuse their spacecraft with it. They might be able to survive for periods of time. Or maybe when we see gray shaped aliens with big almond shaped eyes, that's a spacesuit,
Right.
an organic spacesuit made of organic material. And we think it's the creature. The creature might be under all that. We don't know. Right.
Hmm.
And, when we look at different types of stars, that kind of gives us a clue as to what we might find in creatures out there. All right. So, as an example, all right, let me talk to you a little bit about the different types of stars, and I'll bring
Okay.
up this diagram. Okay. This diagram is a Hertzsprung-Russell diagram. You see, absolute brightness of the star goes up and down here on the left. That's called luminosity. And along the bottom there is temperature, but the temperature is also dictated by the color. If you're looking at something that's actually blue, it's the hottest thing there is in the universe. The blue color is hottest and bluest. And then way over there on the other side, out there, okay, are the red things. And the red things are the smallest and generally the coolest. Now, the smallest and coolest, all right, only applies to that that snaky line you see going down the middle.
Mhm.
Okay, that snaky line is all the stars that are making hydrogen into helium in their cores, and we call that the main sequence. All right, and so those guys are the normal stars. We're normal. How about that? Okay, but
Who knew?
who knew? Yeah.
Yeah.
But if you draw a line up from the M at the other end there, the M's go all the way to the top, and you see the Betelgeuse is an M star up at the top.
Mhm.
But wait, I just said that the M stars are the smallest and the coolest. That's true. But the M classification, the color classification across the bottom there, that just deals with the temperature. It doesn't deal with the size of the star. The luminosity class has a lot to do with the size of the star here. Okay. So there's two things that identify what a star is. It's that color class, right? That spectral the spectral class, okay, what color it is, and then this luminosity class, which tells you how big it is, how massive it is, and thus how bright it will be. Betelgeuse is huge. Because it's so huge, the process going on in its core, which is well over 100 million degrees, all right, is actually not going on the outer layers. It's only the core in Betelgeuse that's doing this, and that core may be 10-20% the size of Betelgeuse, okay, maybe smaller, probably smaller. And what's on the outside is just plasma. Okay, what is plasma? Plasma is just atoms without their electrons. It's protons running around loose and electrons running around loose. It's too hot for them to recombine to make atoms again, so they separate and they run around all separately. That's plasma. But when they're far enough away from the star, then the temperature is cool enough so that those atoms can get made again. And so in the outer atmosphere of Betelgeuse, carbon atoms link to other carbon atoms, silicon atoms, if there's any out there, link to other silicon atoms and make compounds. We have carbon-carbon bonds, and we have other dust out there that's formed. You can actually form molecules of dust out there in the outer reaches of these big, big stars. Keep in mind, how big is Betelgeuse? If you put it where it's big. You know how big it is?
Big?
Yes. Yeah, it's big. If you put Betelgeuse where the sun is, it would go out all the way to just past Jupiter's orbit.
Wow, that's big.
That's
bigger
big.
than big. Mm-hmm.
Yeah, and that's a sphere, by the way. So imagine all the material that has to be inside. That's right when they go supernova, and Betelgeuse is about to. That's why when they go supernova,
go, 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 go.
I know, and it's about 700 light years away from us. So most likely, Betelgeuse, when it does go off, it's probably going to be visible during the daytime here.
Awesome.
We'll see it in the daytime sky if Orion's not up, or in the nighttime sky, it's going to dominate the nighttime landscape. When it comes up, it's going to rise like another sun on the horizon, but a very not nearly as big. It'll be a tiny point of light, but extremely bright, and that'll go on for several weeks, maybe a few months.
Oh, that'd be neat.
Then it's going to fade away, and we'll have in its place a neutron star or a black hole. Now, neutron stars are really cool, but the neutron star is a star where its surface is mostly neutrons. Okay, that's one stage of star death, and the neutrons that you see on the surface are the result of a process called neutronization.
Neutronization, well, makes sense.
Yeah, and neutronization is something that will result in a neutron star. But if the star is even more massive, well, then you can get a black hole.
Is that black holeization?
It's just called becoming a black hole. It should be it should be black holeization. I think you're right. Yeah,
Mm-hmm.
keep steady here.
I think there's a song about that. Mm-hmm.
Yeah, black holeization, black holeization. I mean, But yeah, so but Betelgeuse, when it goes supernova, is going to be a big deal, and it'll probably be it'll be as exciting to our civilization now as the Chinese seeing a star in their sky in 1054 AD. That was a supernova that was visible in the daytime sky as well. And it became this amazing thing. The Chinese studied it. It was just a bright star in the heavens. There was no telescopes back then.
That was just so cool.
It was just a visible light thing with your eyes, visual. Wow, look at that. Yeah, and that became what we know now is called the Crab Nebula. It's a famous supernova remnant, and over the last 100 years, we could see it doing this. We could see it expanding. So it's expanding out into the universe, and we know it just goes, like, if we see it in fast motion, we're going, poof. Cool. But because it takes many human lifetimes to actually see real motion like that, we just see the initial shape and then we can see where it is now from 1054 AD, right when it first happened, and then over the last 100 years, we can see that it's expanded a little bit. So it's going. We're seeing this little piece of it, and 1,000 years from now, it'll still be expanding.
That's so cool.
Yeah. So that's the thing, and neutron stars are really quite frightening. They come in several flavors. One of them is this one right here. This is called a magnetar. Those lines indicate magnetic field lines. You would not see those, obviously. Those are just the lines of to suggest there's a strong magnetic field. And a magnetar and how it forms is a neutron star that's got a massive magnetic field. So after the supernova, this remnant left behind is just about that. It's just a size of a city. So Manhattan Island, that's about the diameter of one of these neutron stars. So make that round, a ball. Okay.
Yes.
Yeah. And they're small. And the magnetar has such a strong magnetic field that if you got near it, it would start ripping apart your molecules long before you got there.
Uh-oh.
Yeah. If aliens have like some type of execution method, that's a good one. You shall be banished to the magnetar. No. and like blah, gone. Ripped into their atoms. Yeah.
You probably wouldn't know it happened.
You probably have some time to figure it out, knowing you're going. But the neutron star,
2 minutes.
Yeah, this is a neutron star. Neutron stars are actually pretty complex creatures, It has a somewhat of an atmosphere. The atmosphere is made of just literally elements of a material left on the surface. Then underneath it, you have this outer crust and an inner crust. And when they say that, you need to understand that neutron stars aren't like the sun, which is a gas giant. Okay, this is a gas giant. All right, a gas star. It's a giant compared to a neutron star, but it's a regular sized star, and it's a ball of hot gas. But a neutron star isn't a ball of hot gas per se. It's highly compact neutrons that are packed together so closely that they resist further compaction. And if you took, and this is what's interesting about this, in the terms of the size, there's the typical size. This is the size of a neutron star over Chicago. Okay, so that gives you an idea how big a neutron star is.
Big.
It's big. That's right. But it's small. If you saw it from orbit, you might see a little tiny round thing. Okay, because it's only the size of a city. But if you think about it, the crust is actually as hard as a billiard ball. Yeah. It's not doing fusion anymore. It's hot. It's exotic in the center. It's that exotic, weird matter in the center, highly compressed. So compressed, as a matter of fact. You ready for this?
How compressed is it?
I will tell you. If you took a cubic centimeter of neutron star and you could extract it and weigh it on the Earth, okay, and there's a million reasons why that's not able to happen, but let's suppose you could. It would weigh 461 million tons.
Tons. Wow.
Right.
Wow.
So, yeah, 461 million tons. That's how much a cubic centimeter of a neutron star would weigh. Now, the other way that stars die is becoming a white dwarf. White dwarfs are about the size of the Earth. And a cubic centimeter of white dwarf material on the Earth would weigh 1 ton. See the difference?
Big difference.
Big difference. 461 million tons, 1 ton. Yeah. So I guess you could say that in general, that's like saying, well, isn't that like, well, you've got like cars weigh about a ton, right?
Yeah.
Right. So let's say they're about a ton. We're talking about 230,500 cars is what a cubic centimeter would weigh versus 1 car for the white dwarf. So that's a cubic centimeter of neutron star, 230,500 cars in weight.
Give or take.
That's give or take a truck.
Yeah. Volkswagen.
Yeah. A little Volkswagen. Yeah, that's right. That's right. A Volkswagen.
Yes.
Yeah. So that's cool. So obviously, these different types of stars, these different end states of stars, are amazing. Of course, then the black hole's the most amazing. Black holes, as we watch in this GIF file, you can actually see how black holes bend light around them, and that's precisely what's going on there. And we're actually watching gravitational lensing occur here. So the galaxy is made into like a strange round. And for at one point, it's making like a strange round thing, a strange round shape of light as the black hole passes through it. Now, because we don't live for thousands of years, only live for a few tens to 100, we don't actually see the black hole pass in front of, say, a galaxy. In that animation, it just shows you what happens when a black hole does that, right? But it's so powerful. The gravity is so powerful that it actually bends the fabric of space.
Wow.
Now, that term is elusive to almost everyone. What is fabric of space?
Yes.
Well, space is not just a vacuum with nothing in it. Space is actually boy, how do you say this in a right way?
Come on.
I know.
Come on, we want to know.
Okay, space is fields. Okay, space is fields. It's gravitational fields. It's magnetic fields, right? And you can actually bend those fields with another field, and so gravity is bending the fields of space. Okay, and as an example, here's another black hole image. Now, this is the black hole image as was theorized by Kip Thorne, astrophysicist. Now, I sat with Kip for 3 hours talking about black holes at one point.
Cool.
And if you think about it, the black hole is what you see in the center. Okay. And now you're seeing an accretion disk. Wait, what's that? It's a disk around the black hole. And truly, if you saw the black hole, it would have a disk of material around it. And that's what we're seeing here. On the near side, we're seeing the disk as it approaches us and goes away from us on the near side here. And that's in the lower right type area. But then what's that thing in the top left? It's like a little lump over the top of the black hole. You know what that is? That's the other side of the accretion disk. And the gravity of the black hole is warping it. So it's warping the light. So when the light comes up off that accretion disk, it doesn't just go straight up like you might expect. The black hole is making the light follow the curvature of space. So you're actually seeing the light waves that are curved over the top of the black hole and heading to your eye. So you'll see an accretion disk in the foreground because those aren't being bent because they're coming to you. But the ones that are trying to come to you from back here, instead of going up, they're going up, okay? But then they're being bent around by the gravity of the black hole. So the overall shape is you see this in the foreground, and then the background is being bent up because the light rays are being bent. So from your perspective from here, that light beam is coming from the accretion disk on the other side. You're actually seeing something that's actually blocked by the black hole. But the gravity of the black hole is bending the light up over the top. And so you're actually able to see the other side of the accretion disk in this image.
And
so that's
Mark, I'm sorry, excuse me.
Yeah,
Would it look
please.
that way no matter what angle you're looking at the black hole from?
Very well put. As a matter of fact, we would see that shape regardless of how we were looking at it. You know,
So
now the only difference is if we're looking at it face down, face on like this.
right.
Okay. Then we might see something a little different. Right. It would be more of a disc shape. But when you've got stuff that's on the other side of the black hole, right, and it comes up, it's going to get warped and pulled toward us. So that's what we're seeing. We're seeing the redirected other side of the accretion disk being bent back toward us. And again, these are brain blasters. I get it, but
Very
that's what
cool,
it is.
though.
Yeah, it is. It's pretty cool. You know. So, so I'll read some of the comments here.
It's got a lot of good comments.
Yeah, it's pretty cool. Yeah, a lot of the people are in the Sky Tour family out there. Evan, who's Skytour fan, is here. He says neutron stars would shred you into atoms. Yeah, their gravity is pretty powerful. A black hole would do it quicker. But definitely, yeah. JSEO 77 says this made my day. I needed to hear something interesting.
Oh, cool.
Yeah, I was very happy to see that. Thank you. Yeah, so everybody loves this. And by the way, guys, listening again at 10:15 tonight, we will be streaming from the Arizona Observatory. We're going to go live because I haven't had enough of talking apparently. So
that'll never happen. That'll never happen.
I don't know. Well, let's talk about what's happening in the second weekend of November. While it's on my mind. In the second weekend of November, we have the Phoenix Boot Camp.
It's the MUFON Boot Camp being put on by Phoenix MUFON.
That's right. Phoenix MUFON Boot Camp. Phoenix MUFON Boot Camp.
Phoenix MUFON 2024.
Yeah, the MUFON Boot Camp. Yep. That's right. And it's going to be very good. It's like, I've been teaching at the boot camp for quite a while now.
Yeah.
And they have it. It's always a pleasure to fly out there.
Yeah. Mark teaches about astronomy and how to work cases and to, evaluate your photos or just, put your, basically everything. There's so much to learn during that camp. It's going to be
fun. There is. There's a lot of qualified people doing the teaching. You're going to learn about photo and video analysis.
Yeah.
And as a photo and video analyst for MUFON, as a chief photo and video analyst for MUFON, I like seeing other people's take on how to do it. And I don't have an ego to bruise, so I think it's great to see other people do that kind of work. Yeah.
I mean, you're going to have a sky tour. You're going to have a sky watch for us, I believe.
Oh, I am. We're going to do a sky watch out at Weaver's Needle.
Mm-hmm.
Yeah. If it's open.
It should be.
Yeah. They closed it for the fires.
The fires are on right now, so
it
might look a little different when we go up there, but should be fun.
Well, yeah. I remember seeing a photo of the Superstition Mountains, which are really majestic and tower over you when you're heading out of Mesa in that direction. And I saw a photo. It looked like a volcano.
Oh,
it's all on fire. Oh, yeah.
Oh.
Yeah, it looked like ribbons of lava, but it was actually fire.
Mm-hmm.
Yeah.
Oh, it was a horrible fire, yes.
Yeah.
And those areas are really difficult to fight because they're up high and very rocky, mountainous. So
yeah,
kind of let it go, sort of.
I don't know if they dropped the flame retardant from the DC-10.
A lot of these fires
slurry.
They have been, so I don't know if they put any specifically there, but you can see it when you're driving down the highway near it. You can see some little red marks here and there.
Where they dropped it on there.
Mm-hmm.
Yeah. Well, let's hope there's no fires when we get out there, because in November it's not 110 degrees, but it's close. It could be close.
It might be. It's supposed to be 114 today. I don't know what it ended up being, but so it might be.
Well, yeah, for you, I mean, you're just 4:30 now.
Yes. Mm-hmm.
4:30 for you.
Yeah,
it's 7:30 for me. But that's good because it means that we'll be able to stream in just a short time compared to you. Yeah. So when you talk about all the things with the stars and the stellar evolution, we have to consider when we go back to that Hertzsprung-Russell diagram, which is the diagram we use as astronomers to classify stars. Where on this diagram would planets that could support life typically be? Okay. Well, we know that they probably wouldn't be in these O-type stars. See the O at the bottom, draw a line up. Mm-hmm. And they're probably not in the B-type stars either. See the B at the bottom, draw a line up. Those stars are very hot and very blue. A lot of their energy that they give off is in the ultraviolet range. And we know as a carbon-based species that ultraviolet light can really be detrimental to any carbon-based life that might be forming. So we are probably not going to see life around planets that may or may not form around those types of stars.
Right.
When you get to the A-type stars, okay, all right, A-type stars, right, stars like Altair and we're looking at Vega Okay, Vega is right overhead when it gets at sunset tonight. You'll see Vega's almost overhead. Okay, Vega is 26 light years away. It's an A-type star. It's an A0 star, meaning it can go A0 to A9. And then when it goes past that, it becomes an F star, G star. Now, they don't evolve in that direction. When you're an A star, you're going to be an A star fusing hydrogen into helium on that main sequence, that ribbon going down the middle, okay, of stars. And then when you stop fusing hydrogen into helium, you go upward in the diagram, and you leave the main sequence and you go into one of those other stages where you become a potential giant star. And again, because the stuff at the bottom is only temperature related, it's not size of the star, you can have a star like Vega that's an A star now, but if it becomes a red giant someday, well, then it'll become an M star, at least by the color classification, but it won't be an M star with a designation of brightness in the luminosity class that puts it back where it is right now. It'd be way up there higher, a much brighter star, because the size dictates the luminosity by the square of the radius. So that's something else. Yeah. So that said, these stars, they migrate on the main sequence upward, right? And they follow tracks. There's evolutionary tracks of stars follow. One's called a Hayashi track. Okay. There's a helium burning phase. There's an asymptotic giant branch. Okay. There's all these different branches of evolution that form above the main sequence up there. All right. But when the stars are finally done, and the stars kind of like the sun and slightly more massive, they will shrink down and become white dwarfs, like you see right there. And that's the realm of the white dwarfs down here. Okay. And those white dwarfs are the ones that are the size of the Earth, right? And they're very, very hot, and they will persist for billions of years like that. Okay. There's no white dwarfs in the universe that have actually cooled off yet. Right.
Wow.
Yeah. And just like there's no M stars like that on the far right bottom of the diagram there, there's no small M stars that are in the main sequence that have died yet. And that's because they last trillions of years. Wow. And the reason is because they keep circulating new hydrogen into their cores, like a pot of boiling water. The water at the top goes down to the bottom, then comes back up. Well, these particular stars, those M-type stars, they're convecting. They're convection, chambers. They actually cycle hydrogen from the top down into the core where it's used, then back up and down all over the star. And that literally makes their life thousands of times longer. Our sun has a radiative zone. So like in the middle of our sun, the center of the core, which is about 10 to 15 to 20% the size of the sun, that's a radiative core. It's radiating out energy. And then in the outer layers, in an outer layer on this scale, maybe like this thick, okay, in this scale, okay, maybe like that thick, okay, that much of the sun is actually doing convection, right? And the rest is all radiative. And so this star our sun doesn't ever take the hydrogen that the star is made almost entirely of out here and in the interior and bring it down to the core to get used. This is all hydrogen that's along for the ride and will never get used to make any new fusion. It's just the hydrogen gas and other elements and so forth that the sun was formed with. And that's what we see here with the sun. So stars are furnaces that make new elements. Yeah. In fact, going back to our diagram we showed a little earlier, stars make all these different elements. If you look here, the Big Bang made the ones in blue, so hydrogen, okay, and just a little lithium, right, and helium. Those are made with the Big Bang, and then more was made after, of course, all right. But then you look at the green stars, like the sun, also have another process by which it can make these other elements that you see. And then neutron stars, the ones that are about the size of a city, when they merge, and we've seen merging neutron stars, they create many of these other elements in the purple. Okay, and when white dwarfs get involved with a red giant, the white dwarf could gain more mass than it can. It reaches a specific threshold, and it'll blow up and go supernova, and creates the elements you see there from 18 through 30 in the periodic table. Right. So in other words, star factories make the elements we see in our periodic table. Right. And when they burn material and they fuse, this is a typical. This is the outline for a star that's massive. Okay.
Okay.
And so you see that there's all these shells. The outer part becomes a hydrogen burning shell, then helium, carbon. The hotter it gets, the more elements it can burn. And that's just the core, by the way. Okay. That's just the core. All right. It's not the rest of the star's envelope. The entire envelope would be about the distance to Jupiter. So like Betelgeuse is probably doing what we see right here. So it's probably making all these elements. It's making oxygen into further elements, neon, carbon, helium into further elements. And helium goes into carbon, carbon goes into neon goes to oxygen, oxygen goes into silicon. And silicon, what's interesting is when silicon burning occurs in a star, now we have silicon here. It's sand. It's on all our beaches, right? We have silicon compounds all throughout the solar system. I think you'd be amazed to discover that when a star starts making silicon, that only happens for 1 day.
One day. One Earth day.
One Earth day in the lifetime of several 100 million years for these big stars. Wow. 1 day is what it makes silicon in.
Just right? So
it
fast?
Makes the silicon. Well, what it's doing is it's doing it, okay, for 1 day, because that reaches a threshold where after doing the silicon burning, then there's nothing else. And the star is pushing outward with this radiative energy, okay, trying not to collapse from the gravity, trying to crush it. And if that all stops, then this all starts coming crashing down from all sides. Okay, it's like a freaking power press. The core is crushed.
Wow.
Okay, and that causes all kinds of things to happen in rapid succession. And one thing that's really interesting about it is if you look at a supernova event, which is what this would be, okay, as the core is being crushed, okay, this other material is crashing down on it. Well, it can only crush so far. Now, these big stars have iron in their core that doesn't crush any further, and you can't do anything more with iron. You can't fuse iron. So what happens is all this mass from all around the star that was the size of Jupiter's orbit, okay, crushes down, and then the interior core, all the stuff hitting the interior core rebounds and starts going back out as this other stuff is still coming back in. And so you got stuff going by each other on the way out and on the way in. And in there is also a flood of particles called neutrinos. And neutrinos are what signal a supernova coming. And here's what we can do with this. When Betelgeuse sends us a stream of neutrinos, those neutrinos are getting out because they're traveling at light speed, okay? But they're not impeded by anything. Neutrinos go right through you. You've got, just in your hand, you got millions and millions of neutrinos going through your hand every second, okay?
Ow.
Yeah, maybe millions, okay? And you can't stop them, all right? So we can stop them with the Earth by using deep pools of special water in mines. And we have neutrino detectors that can stop 1 in a billion of them. And we can actually see that they came from someplace. And so, that said, these neutrinos can make it out of the surface of the star and head to the planet. But the actual supernova explosion isn't happening at light speed. It's physical material moving outward from the inside of the star. That physical material moves far less than light speed. It moves at supersonic speeds, and it will take hours for that spreading shockwave from inside the star to breach the outer surface of the star. What's that mean? It means that we would be able to know a supernova is coming by seeing the neutrinos hitting us first. So if we see a burst of neutrinos, and we're watching Betelgeuse, if we see a burst of neutrinos coming from Betelgeuse right now as we speak at 7:40 p.m. Eastern Time, that means that sometime tomorrow morning we might see the breach of the surface and the supernova will have begun.
Oh, cool.
But it's already happening. By the time we see the neutrinos, it's already underway. It just hasn't breached the surface of this massive diameter star. Isn't that cool?
Mm-hmm. Isn't that 700? Is it 700 years ago that it happened? If we're seeing it,
good, very good memory.
Okay.
If we're accurate on its distance, it's 700 to 750 light years away. So as of now, it could have already blown up. And
Mhm.
if you could just instantly transport to that location in space, you see a supernova remnant. Okay, and that's all you'd see. However, in a neutron star or a black hole, but it's possible that it hasn't actually blown up yet. But when it does, the light train with all that information is coming to us, right? And as it reaches us, the neutrinos get to us first, and all eyes will be on Betelgeuse. Keep watching because it's coming. And they'll actually be able to predict when they see the neutrinos. If they see the neutrinos from the moment they start, they'll be able to predict exactly when Betelgeuse will go supernova.
Oh, cool.
I'm sure it'll be a televised event.
I would say the whole world will watch. I would think. I would think.
Yeah. And if it's a daytime, we'll stream it during the daytime, and we'll show you the blue sky with our telescope, and then you'll actually see this beautiful supernova occur, and you'll see the light of the supernova in the daytime.
That'd be so cool.
Isn't that something?
Mm-hmm.
It's really, really something. Yeah. Yeah. So in our vast galaxy with our beautiful Milky Way, okay. Yeah, this shot was taken out there at and this, just so you know, you see the orange on the horizon, not the orange down here. Those are lights that you see, those two little light areas. But that orange on the horizon, that's the sunset.
Yep.
And look we have the Milky Way at sunset going up from the horizon. Isn't that something?
Beautiful.
That's how dark it is out there. Tara knows. She's been there many times.
Oh, so gorgeous.
Yep. We have these guys out there too.
Yes, we do. How pretty. Yeah. It's kind of skinny.
Yeah, yeah. It's a cute little tarantula.
It is.
Yeah.
Pretty? Yeah.
He needs to be hydrated. I don't think he's got enough water. Look at his
he does look skinny.
His abdomen is a little small.
There's not that much water out there.
Yeah. Yeah. I wonder how many people in the audience went, ah.
Mark, this is maybe a silly question. Do all stars have planets around them?
Well, that's not a silly question, because in the past they would have argued that, well, of course not. They would have said to you, they would say, no, of course not. There's no other evidence other than that we're here. Mm-hmm. And that always seemed just wrong to me. So as it turns out, if you remember that Hertzsprung-Russell diagram with the ribbon down the middle, the lower end of that ribbon, the M stars down the bottom, there's more types of those stars in the universe than any other kind. And thus, around those stars, we've discovered that, and by statistical analysis, there's more planets in the universe than stars. And many of those planets are around those types of stars.
Wow.
Now, if you're an alien being coming from that type of planet, around that type of star, there's a number of considerations, a number of environmental pressures that you're going to be under when you develop. Among them is the ability to see. And why would I say that? Now, we assume that beings have eyes, but every life form on our planet has some form of eyesight, whether it's a receptor or eyes of some kind. Every life form. So if that's characteristic of the universe, in the deep caves, there are creatures that had eyes, but then they evolved away because they didn't need them because they were just in the dark all the time. So if creatures evolve on a planet around a red star, there is a consideration that has to be taken into account, and that is that the star is so small relative to our sun that habitable planets are going to be a lot closer to it, okay, to get an equal amount of warmth like we have from 93 million miles away. We might be able to be 20 times closer or 50 times closer to our sun if it was a red dwarf. And then we might just be in the habitable zone for our star at that point. So these red stars have very, very small, narrow habitable zones, and they have tons of planets in some of these zones, as it turns out. I will reference TRAPPIST-1, the star that has 7 planets around it. Okay, 3 of these planets appear to be in the habitable zone of the star. 3.
Cool.
One's too close. The next one's a little bit too warm still. But then you've got 1, 2, and 3, which are just right. With 2 being, well, it's 1, 2, 3, planet 4 being just about at the right level to make an Earth-like environment. Okay,
Cool.
And then 5, 6, and 7. So it's actually, it's planet 5. So there's 7. So you have planet 5 is more or less like the Earth would be if it could be that way. So 4, 5, and 6 would be the habitable ones, and 7 is like just beyond, just a little bit beyond the Mars type thing comparatively. And we're not talking those kinds of distance. We're talking so close that you could actually see the shape of the planet in the sky.
Oh,
They're so close. And not only that,
cool.
you always will, because if you can see the planets in your sky during the day, it means you're always going to see the sky because you're on the day side. Planets that close to their star are also tidally locked. And that means
yes.
that means, like the moon with one side facing the Earth because of tidal locking, these planets will have one side facing their star. So that means on the day side, you're going to need protection from the ultraviolet radiation these M stars can give off, and they do flare a lot. On the sunset side, it's going to be always sunset. My gosh, if you're an artist, you like going to the beach, you're all set. Okay. You want to view the stars? Yay! You just go to the dark side of the planet. I mean, real estate's going to have a boom when it comes to getting these M stars. So you'll be able to go and explore different parts of your planet, but you're going to probably survive best on a part of the planet where you're not going to be subject to as much ultraviolet radiation, and that's going to be the dark side.
Yeah.
Okay. On the dark side of the planet, you might be near the sun terminator. You might see a lot of high winds because you got a very, very warm front side, and that's going to cause winds across to the dark side. So there'll be a lot of mixing, and that mixing, as this atmosphere expands when it gets hotter, it's going to blow right through to the dark side and mix, making it rather a temperate climate on the other side. Now, if you're evolving on that dark side, one of the things that you might discover if you're evolving there is you don't really need to worry too much about color because you're kind of in the dark the whole time.
Oh.
So you might not develop pigment in your skin, kind of like cave-dwelling creatures on our planet.
Right.
They tend to be whitish gray, don't they?
Mm-hmm.
See the difference? See the connection? And if you're going to see, you may develop eyes that are oversized. Don't we report grays having large, oversized eyes?
Mm-hmm.
See the connection? So maybe the gray species, anyway, comes from a planet where it's an M star and they exist on the far side and evolved there. Now, because they probably have multiple planets, they might have spread to more than one of those planets. And there's no reason they can't be technical. There's no reason they can't develop intellect. We can't say, right? We certainly don't have the corner on that market now, do we? Yeah.
Depends on who you ask, Mark.
You're right. Bink,
Depends on who
bink.
you
Yeah,
ask.
you're right. Yeah. So this is what's interesting about these stars. So now we also have, and this is controversial, reports of the Nordics, right? Well, maybe they developed on a planet that was super habitable, if they really exist.
Right.
Okay, and what's super habitable? Well, our planet's not considered super habitable. In fact, it's actually kind of hard for our planet to support life. It's always trying to kill us. Earthquakes, tornadoes, tsunamis,
Yeah.
Okay, volcanic eruptions. Okay, it's always trying to hurt us. Ultraviolet light from our sun, a lot, right? Well, the Nordics might develop on a planet that's super habitable, so they had all the best of the best, right? There you go. And last, I'll leave you all with this. I don't necessarily believe that reptile life exists, like reptilians, as they call them. But can you imagine this? What if a planet's developing and it doesn't have dinosaurs? Well, it has dinosaurs, but the dinosaur life wasn't extinguished like it was here.
Mhm.
Again, what if it was more habitable and didn't have that? What if dinosaurs never went extinct? Would we be reptilian? It's a question.
We might be birds,
Yes.
but yeah.
Birds are ancient ancestors to them, aren't they? No.
Mm-hmm.
Yeah. So maybe reptilian life is something that, as silly as I've always felt it to be, maybe it's not so silly. And that's kind of where we're leaving it tonight, isn't it?
Yeah, it's not so silly, and there's so many different reports, through MUFON especially, and but you just hear of all the different reports of the different types of beings that who knows if they're really out there or not, but it makes you wonder.
It does.
It
Well,
makes
thank you guys. Thank you for watching, guys. It was wonderful talking to you. Tara, thank you so much, as
Oh,
always.
thank you. Thank you, Mark. Thanks, everyone, for coming out and watching.
She's so insightful. She's great, guys. She's really good. Okay, Spock, beam us up. Thanks, guys. We'll see you again.
You guys
Bye.
take care. Bye-bye.